All right, for our next video in subtracting in scientific notation, you may notice that our lead values are not whole numbers anymore. They are decimal values. But again, we're going to break through this problem step by step and show you guys how to evaluate this. So again, my rule for adding and in this case subtracting in scientific notation is that my exponent values need to match in order to evaluate my lead values. Okay, and general rule of thumb, it's easier to make your smaller exponent value into your larger exponent value. So in this case, I'm going to keep my 2.8 times 10 to the fourth minus some number times 10 to the fourth. Again, I wanted to change my 2 into a 4. And now thinking about the balance beam example, let's use orange, okay? Again, I'm increasing my exponent by 2 in this case. So that means I need to decrease my lead number by 2 decimal places. All right, so if I have 1.3, that's my original lead value. Okay, in order to decrease a number, I'm going to need to move my decimal place to the left 2 places. So 1, 2, mark my new decimal place, fill in my zeros. Okay, so now I have 0.013. 0.013. All right, my next step, all right, is that I need to line up my values in scientific notation. So 2.8 times 10 to the fourth minus 0.013 times 10 to the fourth. Now again, we're going to be putting these lead values into our calculator, but just to make our problem look proper, all right, I'm going to ensure that these lead values right here, they all kind of match up. So all I did was I added in 2 placeholder zeros right here. All right, so I know my final answer, you keep the times 10 to the whatever power, in this case it's times 10 to the fourth, and then to evaluate, again, always use a calculator. Always, when you're allowed to, always use a calculator so then that way you avoid any chance of potential computational error. So in this case, I get 2.787, and that's my final answer, 2.787 times 10 to the fourth. All right, beautiful. So again, just kind of to recap, even though in our original problem we had lead values that were decimal numbers, don't freak out about that. All right, just kind of bring it back to the basics. I know my first step, got to get my exponents to match. I want to make it so that my smaller exponent matches my greater exponent. So in this case, I wanted the 2 to become a 4. And now this is the only, I don't want to say tricky part, but this is really the only part that's kind of the heavy lifting. All right, when you have 1.3, all right, and I'm going from a 10 to the second, 10 to the fourth, well, I increased my exponent by 2. Again, we went up by 2. So then I need to decrease my lead number by 2 decimal places. So again, I'll kind of go through it. I have 1.3, that was my original lead number. And then in order to decrease it, to in essence compensate from going from a 2 to a 4 in my exponent, I need to move my decimal place to the left, 1, 2, all right? And then my new number is 0.013, okay? And just to show you really quick that, that these two equal the same thing, watch this. 1.3 times 10 to the second, well, really that's, if I going from scientific notation to standard notation, 1, 2, that gives me 130. Here, 0.013 times 10 to the fourth, okay, I'll move this 1, 2, 3, 4, and that's 130 as well. So both of these are the same. So again, we're really not like changing the value of the number, we're just re-expressing it so then that way we can apply our rule of adding and subtracting in scientific notation, which again is when the exponents match, that's when you can evaluate your lead numbers, okay, these values right here, and then you keep the times 10 to the whatever power it is. All right, anyway, hope you enjoyed this. Thanks, and I'll see you in the next video. Bye.